So good evening, everyone.
Yeah.
Okay, good evening, everyone. Welcome to the monthly Astronomical Society of Penang AstroCafe session. Every time on this session, every month on this AstroCafe session, we share about the monthly astronomical event. But today we have something special, which is we will discuss about the answer for the Penang State Level Astronomy Quiz 2020 organized by Astronomical Society of Penang, which was held this morning. And we will discuss the answers for selected questions. And maybe Dr. Chong say hi to the others.
Okay, selamat datang ke semua orang di sini. Okay, so jangan dinanti-nantikan keputusan itu quiz. So wait for the quiz result. We announce it sometime in the middle of this discussion session. Alright. So biarlah Mr. Lai akan jelaskan itu berkenaan dengan jawapan-jawapan soalan quiz. Alright, Lai, boleh?
Yes, so these selected questions to be discussed is actually the questions with most of the students make mistake in. So without wasting more time, all right, I know most of you maybe were more keen on the results, but we spend a little bit of time on the questions. Hopefully, everyone at the end of session, at least we learn something. All right,
Yeah.
so let's start with question 2. All right. So which of the following sequence on famous astronomer is correctly arranged chronologically? So basically, this is historical questions set by Dr. Chong.
Yeah.
So maybe Dr. Chong, you can make some comment on this.
So this one, of course, first of all, you must understand correctly arranged chronologically. Chronological means by time lah. So among the 1, 2, 3, 4, 5 of these people here, who started the first? All right. So if you think carefully, of course, it has to be Ptolemy, 2,000 years ago. All right. And then I think in the 10th century, our famous what they call Muslim astronomer Al-Biruni. And then sometime in the 12th century, our Go Sojing. Remember the Yuan dynasty in China, the Mongol dynasty in China? He was the top astronomer. And came later we always know that Kepler is before Newton. Okay, so Kepler, all right, and then Newton, all right. So you look at the others, for example, if you look carefully, number A and B cannot be Al-Biruni, the last is wrong because Al-Biruni is in the 11th century, 10th century. So Al-Biruni should be earlier than Newton and Kepler, all right. And of course, the last one sounds interesting because Einstein is the latest, and then you have Newton. The problem is Newton comes first and Copernicus. Tak boleh. Copernicus comes before Newton, and that is a problem. So that is the problem here. So only one here. Number one, Ptolemy, about 2,000 years ago. He's a Greek astronomer working in Alexandria. Al-Biruni, all right, sometime in the 11th century AD. Go Sojing, 12th century China. Kepler, of course, in what they call German astronomer. And then this is Newton in the modern astronomy. So this is the correct one. All right. So if you put all the others A, B, C, D, wrong. So you put C, you have 1 mark. So section A, 1 to 90, number 1 question to number 90 question, every correct answer will get 1 mark. Okay. Right, Mr. Lai, continue.
Yeah, so this is about question number 2. Meanwhile, just remind all of our audience watching this Astro Cafe session, if you all have any questions, all right, you all can interact with us through the comment section on the Facebook Live. All right, so feel free to ask us questions and don't hesitate if you have any questions. All right.
Please scroll up question 3. I don't see. Scroll up the whole question.
So next question is question number 5. All right, question number 5. All right, question number 5 is actually designed by me. It's actually combining the latest technology in the ancient time. All right, so it's actually imagine that this WeChat application was invented 1,000 years ago. All right, and in ancient China. So what will happen? All right, the question is, which of the following is not the contribution of this astronomer? So we have an astronomer here. Let's look at the dialogue over here. So this guy, okay, this one is the emperor. He said, I heard you have came back from Taihang mountain trip. So this Taihang mountain trip is actually a a mountain in China, in northern China. All right. And this is the astronomer, right? This second one. Okay, this is the astronomer. He said, yes, your Majesty, I just arrived Bianliang last night. So Bianliang is the Song Dynasty capital, all right? Is the capital of Song Dynasty. So he asked, how's the trip? Any interesting findings? All right, so this is the findings, okay? And which is the clue telling you who is the astronomer, all right? So he said, from the analysis of sedimental biological fossils in the rocks of Taihang Mountain, it is fair to infer that North China Plain was once the location of an ancient seashore. The seashore shifted hundreds of miles east and land were formed due to inundation of silts from Yellow River, Hutuo River, and Sangkan River. So basically, another clue given here. So this is the first clue, all right, giving explanation on how the North China Plain was formed. And also the second clue is, this is the first scientific explanation of the formation of North China Plain. So according to the history, all right, the first explanation on formation of this North China Plain is based on the sediments and biological fossils in the rocks of Taihang Mountain. So this astronomer, all right, the first person who proposed this theory on the formation of North China Plain is a Song Dynasty astronomer. His name, which his name is Shen Kuo, right? Shen Kuo. So basically, all this four is his contribution. All right, he hypothesized that this atmospheric refraction. He did measure distance between Polaris and the true north, and he realized that the Polaris is not exactly on the exact north. It's slightly off from the north, and that from his measurement, all right, he measured that from the actual north to Polaris, there's a distance about 3 degrees. Okay, but this is a very rough measurement. All right, because at that time they do not have precise equipments for measurement. And for C, improve the design of Norman armillary sphere and clepsydra, which is water clock. Yes, okay. This is basically his contribution. And we know that for improving design of armillary sphere and clepsydra, or we call the water clock, the more famous one is Guo which Dr. Chong did mention just now. All right. But all the improvement of design is basically based on his design. All right. So the earlier version, all right, the first armillary sphere, the first generation armillary sphere is by this Zhang He during the Han Dynasty. And then Shen Kuo is the second generation. And the third generation belongs to improvement done by Guo Shoujing, which is the armillary sphere. All right. And also he discovered that magnetic north is always slightly to the east of the true north. All right. So A is not correct because he realized that atmospheric refraction, instead of from moon observation, he realized this phenomena through solar observation. So in one of his book he wrote, he actually did mention that the apparent sun position, all right, is not the actual sun position. So while calculating the time, all right, using the sundial, all right, the ancient sundial, okay, he actually did provide, all right, corrections to the actual time, to the actual sun time based on the actual position of the sun instead of the apparent position of the sun. All right, so this is basically question number 5. The answer is A. All right, hypothesize atmospheric refraction from moon observation. Okay, the correct one is supposed to be from solar observation. Okay, so next we have question number 7. All right, select the order from smallest to the greatest. All right, this is Dr. Chong's question.
Actually, I think if you are say for many students who knows about basic physics, should be no problem. I don't know why they have this problem here. Of course, okay, we start from the one that we know better, the biggest of course, the Milky Way. All right, and then you say nebula. If you know what's a nebula, nebula, for example, a star that died, blow out all the gases that come out, it form a very big object. Right, so we know that a nebula is much bigger than the solar system. All right, and then come the comet. Comet, remember the south passing, got a long tail, got a coma, so it is actually can be as big as a solar system, but smaller than the nebula. Of course, then you will say, which is smaller, proton or black hole? Some of them may put proton smaller than black hole, black hole bigger, but no. Do you know, if I ask you, what is the size of the black hole? Then someone say, oh, the size of the black hole is the size of the event horizon. No! The event horizon is not the black hole. Inside the event horizon is the actual black hole. So the black hole is actually a point. Even if you have a supermassive black hole, the size of the supermassive black hole inside its event horizon, the size of the supermassive black hole is also a point. All black holes are point. So of course, the smallest to be a black hole, then a bit bigger is a proton, then size of a solar system comet, then bigger than a solar system nebula, and bigger than nebula is Milky Way. So actually, D is very logical. The others you see cannot be. All right. For example, you see that how black hole is bigger than proton, cannot be. A cannot be. And then you see a proton bigger than the nebula, cannot be. And then a comet, what they call a black hole is the biggest object in the universe, cannot. Black hole is a point. So of course, D is the correct answer. Okay, 1 point for D. All right. Select the order from the smaller size to the bigger size. All right. Yeah. D is the answer. Black hole, proton, comet, nebula, Milky Way. Yeah.
Right. So next we have question number 10. All right. Question number 10 is about Kepler's law. So this question is actually slightly difficult, all right, which is set by me. All right. So if you are familiar with Kepler's law, then you might have no problem in these questions. Okay. So the question says, which of the following statement related to Kepler's law is true? So basically, all of this, all right, only one correct answer. So A says all planets in the solar system has an orbit of 2 foci and the sun as the center. All right. So the first part, 2 foci, is correct. All right, because the orbit is elliptical, but the sun is not at the center. All right. The correct one should be all planets in the solar system has an orbit with 2 foci and sun at one of the focus. All right, at one of the focus point. Number B is the time required for a planet to travel two different fragments of its orbit is the same if both fragments have the same distance and sweep out area. All right. This is on Kepler's second law. Based on Kepler's second law, it says that the time required for a planet to travel two different fragments of its orbit is the same if the sweep out area is the same. All right, not the distance. All right, the sweep out area might be the same, but the distance might not be the same. All right, that's why this is not the correct one. Okay, the same distance, this is the part that tricked you all. All right, yeah. And C is correct. All right, if the average distance of Earth from the sun increased by 60%, the orbital period will be longer than 1 mass year. All right, so this is based on Kepler's third law. All right, which is if the distance, okay, increased by 6, which means the distance A, all right, the average distance A become 1.6. All right, the orbital period will be about 700 days. Okay, and 1 mass year is about more than 650 days. All right, somewhere around 650 days. So it's slightly longer than 1 mass years. All right. And D, an asteroid in the solar system was observed to have an orbital period of 5,000 days, is always 4.7 astronomical unit away from the Earth during opposition. All right. 4.7 astronomical unit is correct, but it's not always 4.7 astronomical units. All right. Remember, because the orbit is elliptical. So for elliptical orbit, all right, it is not necessarily always 4.7 astronomical unit. All right. For C and D, the question is based on Kepler's third law, which says that the orbital period, the square of the orbital period, all right, the square of the orbital period is the cube of average distance. All right. The square of the orbital period is directly proportional to the cube of average distance. All right. So if you calculate C and D, all right, you will get the answer as C. And for D, it looks correct, but the problem here is with always, okay, the term always. So it's not necessarily always 4.7 astronomical unit. All right, it can be slightly more or it can be slightly less because the distance is average distance. All right, but the actual distance, it might be more, might be less. So this is not the correct answer for D is not the correct answer. So the only correct answer is C. All right. So we proceed to next question, which is question number 14. All right. Question number 14, Dr. Chong.
Yeah. Of course, what Mr. Lai mentioned is we are discussing those questions where the student did poorly. All right. So we elaborate on it. So question number 14, of course, is LIGO. Bukan Lego, L-E-G-O, bukan. L-I-G-O, LIGO. Okay. LIGO is a Masala way of so they don't say LIGO. The Masala we pronounce it as LIGO. So this is the background. You know that in 2016, big discovery, Dr. Noor Hafizah from what you call University, what you call Islam Antarabangsa in what you call in this UK. Her team in America discovered the gravitational wave. So we look okay. So what is this? Is basically two long lines, two long pipe in the desert in America. Two of them, they have two what you call optical beam, all right, that interfere. And if there's a supernova that explodes somewhere or two black holes collide, so the shaking of the space-time, goncangan ruang masa, space-time will be shaken, and the space-time will travel at the speed of light. And these two perpendicular beam will be, one of them will be shorter, one will be longer. So basically, the light beam in the one of the tunnel will be shorter a bit, and the other one will be longer a bit. So when you interfere it, the phase change will be different. So remember, phase change means one of the light beam is ahead of the other beam by slightly. All right. So the answer should be B. So the interference of two perpendicular long laser beam to detect that's like phase changes. Why is the phase changes? Because one of the beam becomes longer, one of the perpendicular beam becomes shorter. So when the light travel in a longer part compared to another beam in a shorter part, so when you add them together, there's a slight phase change. Phase change means you measure which one is leading or lagging. A cannot be because interpreting of two long distance beam to detect very slight wavelength changes. The wavelength don't change. The wavelength remains the same in the two optical pipe. It's only the phase that changes. C, interference to detect very slight intensity changes. The intensity of the laser beam don't change. It's only the phase that changes. D, to detect very slight diameter changes. That means the beam, the first beam and the second beam, 90 degrees, the beam will become bigger, diameter, small. No. They don't change at all. So, right? So actually it's very slight phase changes. Right? So we say this way, you must know general relativity and also must know what? Optic interference of light. Optic. So for example, in school, you do what's called Michelson interferometer. Right? So that's it. So B is the answer. So you answer B, you get one mark. You don't answer B, you get 0 mark. Okay? Okay. So Mr. Lai, continue.
Number 15, Dr. Chong.
Yeah. Okay, 15. Now this one is actually very standard. We should know that. Everyone should know that what happened in the sun is nuclear fusion, no doubt about it. So the sun will fuse. We know that maximum amount of material in the sun is 75% is hydrogen. It was 21% of helium. So now the thing is, we know that the sun converts hydrogen to helium. That we know, hydrogen, helium. So after helium, what will happen? So you have the helium will convert, and then you have more and more of the proton coming in, and then the helium and will combine, and finally you combine the helium to carbon and oxygen, and that's all. So at the end plate of the sun, when the converts helium to carbon and oxygen, the sun will expand to call a red giant. All right. So that's it, because the temperature in the sun right now is 15 million degrees Celsius, but we convert from helium to carbon oxygen is much hotter. The sun expands to call a red giant. So basically from hydrogen to helium now, and when all in the center, hydrogen converts to helium, only helium, then helium burning will start, not helium burning in the sense of matches, nuclear fusion. So helium will fuse into carbon nucleus and oxygen. So it should be B. All right. The other one is B is the answer. So whereas A is wrong because here it says hydrogen to helium, helium to carbon, okay, oxygen and nitrogen. It doesn't fuse on nitrogen. So nitrogen is not in the stellar nucleosynthesis cycle here. C, helium to hydrogen to helium always, helium to oxygen and nitrogen again cannot be. No nitrogen is involved. Nitrogen is other factors, all right, other process coming. D, hydrogen is helium, helium to oxygen and falling into iron cannot be. All right, the sun is not a what you call a red supergiant like Betelgeuse. So Betelgeuse will convert hydrogen to, so for Betelgeuse, D will apply. Hydrogen to helium, helium to oxygen, and finally to iron. But sun is not Betelgeuse. It can only fuse at the most to carbon and oxygen only. So B is the answer. So you answer correctly B, you get 1 mark. All right, Mr. Lai.
Next, question 17. All right. Question 17 is about the questions about the solar system. All right. So this question 17 is set by me. The question says, John decided to conduct a research on environmental effect on Venus on different types of materials. He designed a chamber which could simulate the environment condition of Venus and place samples of different types of material in it. So which of the following samples could survive until the end of the experiment? So for Venus, we know that the environment, okay, is quite extreme, all right? The temperature is very high and also the environment is acidic, all right? It has carbon dioxide atmosphere and it has sulfur components inside. So it always have acid rains in Venus, all right? So for A, plastic, of course, it will not survive the high temperature in Venus, all right? And for carbon fiber composite, carbon fiber itself, it will survive at the temperature. Unfortunately, the resin of the carbon fiber, all right, the fiber itself will survive, but the resin itself will not survive, all right? So carbon fiber composite is not the correct one. And steel is still can survive the high temperature, but still might not survive the acidic corrosive environment in Mars. So the only correct answer is ceramics. All right, ceramics can be glassware, can be porcelain. All right, so ceramics. And at high temperature, ceramics can survive. Okay, for example, in your chemistry lab, all right, you all store the chemicals, especially like those high concentrated hydrochloric acid, right? Highly acidic, right? Through you use the glassware, right? You store inside the glass bottle. So ceramics, all right? Ceramics were able to survive, all right? Or even if you need to burn something, you will put on a ceramics tray, all right? So ceramics would survive at the extreme condition of Venus, all right, which is mainly acidic and also high temperature or extreme low temperature. All right. So next we have question.
Right. I would like to comment on this question. So
Yeah.
question 7, I find to be a good question. You know why? Because many of you may think that, astronomy is planet la, Venus la, nebula la, gravity, mathematics. No. Astronomy also what? Properties of material. Like what Mr. Lai say, you go to Mars, you have to understand how the properties will last on Mars. Then you want to build a rocket to go into space, how will the properties react to space? So the properties of materials also come in. All right. The physical properties, the electrical properties, the chemical properties, and so on. All right. Okay. Next question.
All right. So next we have question number 24. All right, question number 24, surprisingly, is a short and simple questions. All right, which of the following is not the source of internal heat of planets? So, each planets we receive a lot of heat, right? But the main source of heat is basically from these three, all right? Solar radiation, gravitational contraction, and planetesimal impact. All right, solar radiation, of course, every day we have heat from the sun. All right, especially in Malaysia, sometimes we feel very hot. Okay, we say it's a sunny day, it's very hot. The second one is gravitational contraction. So basically, for gravitational contraction, all right, due to the effect of gravity, heat is produced. All right, this is the core activity. This is the core activity on the core of the Earth or core of the planets. And planetesimal impact is actually the impact of, for example, meteors or impact of asteroids or small asteroids. These are planetesimal impact. For planetesimal impact, when these so-called objects or small objects or meteors or either small asteroids, all right, enter the Earth atmosphere, it starts to burn, all right, because it enters at a very high speed, it starts to burn. When it starts to burn, it generates large amount of heat. Of course, we don't feel the obvious increase in temperature, but this actually did provide a little bit of heat to the planets, all right? Except for nuclear fusion, all right? Nuclear fusion is not the correct answer because only stars, only in the core of the stars, we have nuclear fusion. For example, our sun, all right? It generates a large amount of light and heat through nuclear fusion. So for for planets, all right, we don't have nuclear fusions because we don't generate large amount of light and heat. All right. So the answer is A, nuclear fusion is not the source of internal heat of planets. All right. So surprisingly, I was slightly surprised when this question, many of the students didn't do it correctly. All right. So never mind. We proceed to question 31. Right, Dr. Chong?
Yeah, okay. Now, question 31 needs your understanding of what's called a star chart. All right. Because star chart, you must know locate your constellation, number one. And number two, you must know what the second one is. You must know your geography, global geography. So I repeat, Namibia is a country in Africa, South Africa. No? That means Namibia is in the southern hemisphere. All right, South Africa. Ideal place to conduct astrophotography is famous, you know. So which of the following constellation can be observed in Namibia during the winter solstice? So that means Namibia is a place in Africa. You look at you know the geography of Africa. Namibia is just not of South Africa. So basically, Namibia is like somewhere like Australia, the southern latitude of Australia. So in winter solstice means what? Means that, so when you say winter solstice, this means that this is for the northern summer, for the northern hemisphere. So for the northern hemisphere, winter solstice is what? December 21st. So at that time, the sun is further south, right? Further south. So now that basically is, which of the constellation can be seen from Namibia? Of course, we know that Ursa Major, number B, Ursa Major and Draco is out. But these two are near the North Pole. But Namibia near the South Pole, so B is out. And Cygnus and Lyra are also in the northern constellation, quite far, quite close to the North Pole. So basically, from this Namibia, you cannot see Cygnus and Lyra, so C cannot be. All right. So now Sagittarius and Scorpius can be seen if you are near the equator. So basically like this. So like this. But then you see, you look carefully, only Eridanus constellation, the River and Phoenix, can be seen from Namibia. All right. Because Sagittarius, if you can see from Namibia at daytime, say nighttime, Sagittarius. But Scorpius is 12 hours away, so Scorpius is daytime. So both can be seen. Sagittarius and Scorpius can be seen in Namibia, but Sagittarius seen in daytime, Scorpius in nighttime. Whereas no. But this means that at the same time at night, from Namibia, which one you can see? So only the two last constellations of South, Eridanus, the River, and Phoenix can be seen from Namibia. So D is the answer. All right. Okay, right. Continue.
Next, we have question 33.
All right, so this is an interesting one. So basically, we know that there are now a lot of telescopes. The world's biggest single mirror telescope is Gran Telescopio Canarias in Spain. So the diameter of primary mirror is 10.4 meters, whereas in Southeast Asia, it's called Narit near Chiang Mai, 2.4 meters. All right. So basically, comparing the Grand Telescopic Canarias 10.4 meter diameter primary mirror and Narid Observatory with 2.4 meter diameter primary mirror, which how many times more light can the first telescope collect compared to the second one? So you say, oh, 10.4 meter divided by 2.4 meter. Wrong. Remember, the light collecting power is proportional to the area of the primary medium. Luas dia. Area. So it should, the correct answer should be 10.4 squared divided by 2.4 squared. Or 10.4 meter squared divided by 2.4 meter squared. So the light collecting power depends on what is the area of the prime mirror. So 10.4 meters squared divided by 2.4 meters squared, you get 18.75 times. So you see, 10.4 divided by 2.4 is about 5 times, No, the area is actually 18.75 times bigger than Grand Telescopio Canarias. So comparing the light collecting power, never divide the diameter, divide the square of the diameter. All right. So D is the answer.
Right, next we have question 35. All right, for question 35 is test a bit on your understanding of using a telescope. All right, so question 35 is set by me. All right, which of the following is not the measurement of resolution of a telescope? All right, so when we talk about resolution of telescope, we actually talk about measurement of the angular distance. All right, that means if we have two objects very close together, whether can we see it as two separate objects or we see it as a single object. Okay, if low resolution, then you will see two very close objects maybe as one object. All right, if high resolution, then you can see it very clearly as two objects. So number one, it says ability to magnify distance object. All right, we don't actually measure the resolution of telescope by whether it can magnify distance object or not, because basically if you have a convex mirror, if you have a convex lens, all right, it have this magnification ability. All right, so simply a piece of convex lens is already have the magnifying distance of magnifying ability. So that's why if we know about this, then it's a little bit not very suitable to be the answer of measurement of a resolution of telescope. Number two is ability to measure the distance between object. To measure the distance between object, all right, the trick is the answer of this. The trick is distance, all right. For resolution, we measure about angular distance, but then over here it said the distance. Through a telescope, we cannot actually measure the distance of the two objects, all right. Because the universe, all right, in the universe, the space is 3D, three-dimensional, all right. So even if we see two stars very near to each other, all right, it might be very far away, a few thousand light years or a few 100,000 light years away. So, and through telescope, all right, it's actually very difficult to measure the distance of two objects. All right, and aperture size is not related to the resolution of the telescope, and also light collecting efficiency. Aperture size and light collecting efficiency. Light collecting efficiency is actually related to the aperture size, all right, but has nothing to do with the resolution of telescope, right? The bigger the aperture, all right, it might have a larger light collecting efficiency, or a smaller aperture telescope. That means if you have a 8-inch telescope and a 5-inch telescope, the 8-inch telescope will have a higher light collecting efficiency, but the 5-inch one will have a lower light collecting efficiency because it is smaller. All right. So light collecting efficiency basically is a measurement of the ability of the telescope to collect light. All right. So it's not about the resolution of the telescope. So none of it, okay, 1, 2, 3, 4, none of it is a measurement of the resolution of telescope. The resolution of a telescope is the ability to measure the angular distance between objects. All right. So this is about question number 35. Then we proceed to question number 40. All right, Dr. Chong.
Yeah, okay. Thank you, Lai. Okay, so we now know that the French astronomer Charles Messier, now, Malaysian sebutan salah. Charles Messier, no, Messier. Charles Messier came out with famous Messier catalog, 110 astronomical object look like comet, but they are not comet. So if you look at the whole list, some of you may not know what's a Messier catalog, but if you know astronomy, you should know its catalog. So you have a lot of objects like globular cluster, star cluster, nebula, galaxies, and so on. It's very simple. You can go through the list. Easily, the biggest number of Messier objects are the galaxies. All right, because galaxies look like comet, but they're not comet. Nebulas, after galaxies, the second one should be, I think, the nebulas. Many are nebulas, and then the third is most numerous globular cluster, and the least numerous is star cluster. But the most numerous, I think many a big percentage, maybe more than 1/3 of the Messier objects are galaxies. All right, so these are galaxies. All right, B is the answer.
Right, then we proceed to question number 64. Right, it seems like question from 41 to 50 something, everyone did quite well. So we have question 64 now about Doppler effect, Dr. Chong.
Okay, so basically, this one is like this. So of course, when you say Doppler effect, straight away when you say Doppler effect, you must go Hubble's law also. So this is due to the expansion of the universe, right? So basically, the Doppler effect says that it applies for anything of wave phenomena, not only electromagnetic wave, even sound, earthquake wave, anything of wave can be applied. But in this case, it's electromagnetic wave. So we know that if any object that can either scatter light or emit light that comes towards you, the light is blue shifted. Blue shifted doesn't mean the light become blue. It means that the wavelength is shortened. Shortened means closer to the blue. That's blue shift. But it goes away from you, all right? The light will be red shifted. Red shifted doesn't mean it become red color. It means that it's shifted to the longer wavelength. So now is that if we have a galaxy now, so this is a galaxy redshift at the wavelength of 1000 nanometer, all right? And then when it measured, what they call, it's a wavelength of 200 nanometers. So this is the detail is like this. Let's say in the spectrum of the galaxy, there's a certain line, spectrum line for the calcium 2 line. Calcium 2 line means calcium has lost one electron. Calcium singly ionized, because in astronomy, calcium 2 means singly ionized. Calcium 1 means neutral calcium. So calcium 2 has one line, and in measure, that line is 1000 nanometer. And it compared to the neighboring lines of the galaxy, they are sure there is a calcium 2 line. And then in the laboratory, they also do the same experiment for the calcium line, 2 line, and they find that the calcium 2 line is 200 nanometer. Wow, that means it's stretched a lot. So once you know that lab is 200 nanometer, in space 1000 nanometer, so it's actually a galaxy flying away from us at very far away. So basically, the redshift is that the wavelength of the light minus the original wavelength divided by the original wavelength. 1000 nanometer minus 200 nanometer is equal to 800 nanometer, isn't it? Divided by 200 nanometer. So the redshift is plus 4. Redshift, answer B, is Z is equal to plus 4. You will put D, minus 4. So in conventional term, plus 4 means redshift. Minus 4 means blue shift. So if we put minus 4 is wrong. It should be plus 4. Right? So the answer is B, redshift. So in fact, if you look at the question, 1000 nanometer actual measured spectrum, but the laboratory redshift is 200. Wow, you should know that it's a very big redshift already. So B redshift Z is equal to 4. Thank you. Lai.
All right, next question number 66. All right, question number 66 is set by me. It says, which subject listed below is not a prerequisite for students from School of Astronautics who involved in designing a spacecraft? All right, so the key word is prerequisite. That means it's not a must subject, or so-called a core subject for students in School of Astronautics. All right, to design a spacecraft. Now, to design a spacecraft, first we need to identify the mission to see which mission. Of course, if it is an astronomy mission, introduction to astronomy is a must. But if it is not a astronomical mission, for example, we are sending a communication satellite. We send a remote sensing satellite, all right, to monitor a certain area or for communication purpose or for your internet purpose, all right. Then introduction to astronomy is not actually necessary. Whereas the others, we have orbital mechanics. For every satellite sent to the space, all right, to orbit the Earth correctly, orbital mechanics is the basic. Orbital mechanics is not only study about which orbit we go, okay? Also study about the calculation of the orbit. That means how fast the satellite should, or the spacecraft should travel, all right, so that it can maintain in the orbit, or how far it should go, at which position, or how it should transfer. If it is a simple mission like remote sensing or communication, or even though like big spacecraft like ISS, all right, which orbit we should go. For example, ISS, we stay at low Earth orbit, which is around 200 kilometers. For communication purpose, we need to have a fixed position, right? The satellite must be always be there, all right? If not, then you might have communication loss. So you have to go to geostationary orbit, which is about 35,000 kilometers. So all this is in orbital mechanics. All the calculations and also all the characteristics of the orbit is in this subject. And then, of course, principle of communication for all spacecraft is a must. All right, when you send something to space, you don't have someone up there. Even though you have someone up there, also communication is very important, because up in space, all right, of course, now we say we have this artificial intelligence, AI, all right, but then communication is still very important. We need to enable the function of communicating of the spacecraft and the ground station, all right. We need to keep track on how the spacecraft is performing, the attitude of the spacecraft, the performance of the spacecraft, or if we have anything special we need to execute on the spacecraft. The communication is very important, all right. So principle of communication is a must. And structure mechanics is also a must for designing a spacecraft, all right. We don't want that our spacecraft we launch halfway, or it works halfway and it dismantle in this space, or it breaks, or something happened on the structure side. So structure mechanics is important. We need to calculate, all right, the structure to make sure that it can survive all the loads, all right. The extreme loads, all right, we have different types of loads. The thermal load, the stress, the shear, the extreme, the highly vibration environment. So structural mechanics is to make sure that the spacecraft we design can survive the extreme launch environment and also the extreme space environment. So orbital mechanics, principle of communications, and also structure mechanics is a must, or a compulsory subject. Or a common term we use in the school is it's a core subject for students studying or involving in designing a spacecraft. Whereas introduction astronomy, we call it is an elective subject. That means you can choose whether you want to study this subject or not to study this subject. So introduction to astronomy is actually elective subject, all right, for students to design a spacecraft, unless it's specified in the questions that designing a spacecraft with the mission to explore something, or for astronomical mission, then introduction to astronomy is a core subject, or else it will be an elective subject. All right, so this is about question number 66. Then we have question number
Wait a minute,
67.
well, let me comment. Actually,
Yes.
question 66 is excellent. Why? It shows to the student that what if you want to pursue a career in astronomy or aerospace or whatever, what is the type of course you are going to do in to prepare yourself to go to university. So this is an astronomy career question. It's a very good question. Okay. Next one, Mike.
Right. So next we have question number 67. All right. For question number 67, it says, which of the following space exploration mission spacecraft does not exist? All right. So this question is actually is quite simple. All right. We have Saturn moon lander, which we send a lander to Titan, the Saturn moon. We have asteroid lander. We have a few asteroid lander. All right, including the Rosetta from Europe, the Japanese Hayabusa. All right, landing on asteroid. And dark matter exploration is by China. All right, they're exploring for dark matter. All right, dark energy and dark matter exploration. They send a satellite named the Wukong satellite. All right, using the legendary tales from ancient Chinese story, the Monkey King God. All right. So the Monkey King God, they have this dark. So they use the satellite name by that. All right. So it's dark matter exploration. Whereas Jupiter Moon Lander, all right, Jupiter's moon lander. For Jupiter's moon lander, this mission initially it was, if I'm not mistaken, initially it was planned, I think, in early to 2010, but then this mission was later cancelled, and only recently they relaunched a mission to send the European Space Agency. All right, they only relaunched this mission, okay, together with NASA, okay, which, sorry, should be NASA. NASA, they relaunched this mission. They want to send a spacecraft, all right, to explore Jupiter's moon called the Europa. All right, they are sending Jupiter's moon, they are sending a spacecraft to, or the orbiter, to Jupiter's moon called the Europa, and it's expected to launch in 2024. So the spacecraft haven't exist yet, all right, currently still in design stage. So the answer is D, Jupiter's moon lander, all right. They haven't have the spacecraft to land, or they haven't have a lander to land on Jupiter's moon yet. All right, but soon, all right, it will launch. All right, in around 4 years' time. All right, there will be a mission to Jupiter's moon. So next we proceed.
General comment.
Yes.
Question 67 is also good, right? Astronomy is not just nebula, galaxy, and then telescope. It's about exploration, space exploration. So this is actually unmanned exploration of the solar system. And also other questions could be related to manned exploration of solar system. So you're going to explore the solar system, unmanned exploration is also part of astronomy. Okay, the next question.
All right, next we have question number 69. All right, so question number 69 is also set by me. It says that a solar-powered lunar rover was awakened on the 1st September 2020 to continue its exploration mission. Based on the record, it's the 20th lunar day of the rover working. All right, which of the following is possible launch date of the rover? So over here, it gives us 4 dates. All right. 28th of July 2020, 30th of June 2019, 24th February 2019, and 11th January 2019. So based on these 4 dates, before we decide which is the possible launch date, all right, first we need to know, it says 20th lunar day. So for the 20th lunar day, one lunar day is about one Earth month. All right, on Earth is about 1 month. 1 day in the moon is about 1 month in the Earth. All right. So it's impossible to launch on July 2020 on the same year they have. That means it's already 20 months on Earth. Okay, it's 20 months on Earth. There's only 20 days in moon. So it's impossible to launch on 28th of July 2020 to get 20 days on the moon. And then 30th June, all right, is about 1 year earlier, all right, which is also impossible. So next we have 24th February and 11th of January. For 24th of February, all right, you can get the 20th lunar day. But then don't forget something is when you launch, all right, when you launch the vehicle, you launch from Earth, it needs some time to travel to the moon, all right? So usually if it is fast, it takes around 3 days, 3 to 4 days. Or if it is not fast, all right, it might take a longer time, or even up to 1 week or 8 days to reach moon, to reach the orbit of the moon. All right. So if you launch on 24th of February, all right, we have one lunar day is about 29.5 Earth day, 29 days on Earth. So if you calculate back, if you launch on 24th of February, all right, if you launch on 24th of February, you will reach moon, let's say on end of February, 28th, or we say 1st of March. All right. If you reach 1st of March as the first day, then it will be the 19th lunar day of the rover working. All right. So the only possible launch date, okay, the only possible launch date for the rover to work on 1st of September as the 20th lunar day is on 11th January. So maybe it is launched on 11 January and then it goes some orbital mission before it lands. All right. So maybe it takes up maybe 1 month or slightly less than 1 month, and only it lands on the surface of the moon and start working. All right. So the answer is the 11th of January 2019. All right. So this is to test whether you know that the lunar day, all right, compared to Earth day. All right. So if you are aware of that, then you can get the correct answer easily. All right. So this is about question number 69. And we proceed to question number 73. Dr. John?
Wait, I think, oh, yes. Okay. So remember, recently, a few months ago, July, United Arab Emirates Al Amal, Hope mission on the way to Mars. And it's going to orbit around Mars. And then Chain 1 mission is to orbit Mars and put a lander on Mars. And then, of course, the most fantastic Perseverance mission will land a patient, what they call robot on Mars. So basically, what is the reason that these missions are launched in July 2020 and not any other month? So basically, the general answer is to use the least fuel to travel from Earth to Mars. Okay, so of course, D is the correct answer. Let's go at A. During the month of July 2020, and Mars is closest to the Earth. Wrong, cannot be, because see, you have in the center the Sun, the third planet, the Earth, and imagine the Sun, Earth, Mars is in a straight line. So it's called what? Mars is in opposition to the Earth law. So in that case, but you said closest what the Earth, you can see Mars vertically overhead you launch. But you must understand, as you launch the rocket from the Earth will orbit around the Sun faster. The Mars will orbit the Sun vertical different. So by the time you reach the Mars will go to a different position. So you in traveling in the space in the solar system, you never fire your rocket when the object you are going to aim is closer to the Earth. You fire at a different time, such that when you fire, you calculate the number of time law that they say July to February next year, how many months later. So by the time so many months later, the distance travel will be the shortest, not directly when it's in a straight line. Okay, because when you fire, the mass will go away, Earth will go away. So it's not A, it's not A. So during the month of Mars, so basically A and B are quite similar. So so the Sun, Earth, and Mars are in a straight line. Mars in opposition. You also don't launch, not the closest to the Earth. The Mars is launched. Wrong. See, from July 20 to 21st, the three missions are the geostationary transport orbit. The trick word to know is wrong is geostationary. Geostationary means a rocket that is orbiting around the Earth that is going to transfer from one orbit to another orbit around Earth's orbit around the Earth. So cannot be this going to Mars. So cannot be geostationary. Okay. So now it's like that. The three missions are on the way to Mars on what's called the Hohmann transport orbit. The Hohmann transport orbit is not in a straight line; it's in a curved line, where the actual energy required to travel from Earth to Mars is minimum. Okay, some will say, no, America so powerful, the rocket very powerful, they can travel from Earth to Mars in a straight line. No, even America so powerful, the rocket so powerful, even then, if they travel in a straight line, they don't have the rocket with that type of fuel. So they must have jimatkan bahan bakar, save the fuel. They have to go on the Hohmann transport orbit, okay, to Mars. So D is the correct one. So remember, when you fire the rocket from the Earth's surface to leave the Earth's orbit, all right? So when you fire towards Mars, that few minutes inject into Mars orbit is the time you fire the rocket, then shut down the rocket, stop. So most of the time, more than 99% of the time, traveling from Earth to Mars, it doesn't fire any fuel. No, not a lot of fuel. Only when you reach Mars orbit, you have to brake, fire fuel to inject into Martian orbit. So most of the time, traveling is quiet. Senyap, quiet on the Hohmann transport orbit. So D is the answer.
All right. Next, we have question number 88. Dr. John?
Yeah. Okay. So now this is we are comparing a radio telescope and optical telescope. So remember, which statement below is completely true, no? So A, B, C, D, you have to choose one of the A, B, C, D, where every single statement in A, B, C, D is completely true. So you may have, because you see the answer is a very long answer. Each answer is made up of many, many small answers. So let's say you have one long answer, one of the small part of the answer is wrong, so that is not correct one. So you must choose one answer, a long answer, where every single part of it are correct. All right. So now you look carefully. Let's look at the correct one first, B. Yeah. So you compare the radio telescope with the properties of an optical telescope. I hope everyone knows what's a radio telescope, radio astronomy, and optical telescope, optical astronomy. So B, look at B, correct answer. A radio telescope has a larger diameter than the Newtonian telescope. That we all know. So in all the answer, radio telescope has a large diameter. This is the type of telescope that use a dish. All right, a dish, just like your astro dish. But radio telescope have much bigger dishes than that. Okay, because radio waves have longer wavelength than visible light. That we know is true. Radio waves usually have longer wavelength than optical light. All right. So then the parabolic shape of the radio dish, all right, is less accurate than the parabolic shape of the primary mirror of the Newton telescope. So many of the radio telescope parabolic dish, the radio dish are parabola. And the primary mirror of the optical telescope, Newton telescope, are also parabola. But because the wavelength of radio waves is very long, all right, so you need not to have a very accurate parabolic shape of the radio telescope, all right. Whereas for the optical telescope, primary mirror of the Newton telescope, your parabolic shape must be very accurate. So also the parabolic shape of the radio dish is less accurate. Less accurate means it can be a bit rough, never mind. No need to be very smooth, all right, for the radio telescope as compared to the primary mirror of the Newton telescope. So B is correct. If you look at the A, for example, I look at the second part of A, also the parabolic shape of the radio telescope is as accurate as the parabolic shape of the primary mirror. Wow, radio telescope parabola as accurate, no need. The radio telescope parabola no need to be so accurate. Less accurate than a primary mirror. So as accurate, A wrong. C, all right. Second part of C, also parabolic shape of radio is as accurate as the parabolic shape of the primary mirror. So it's not as accurate, right? Because for C, okay, because you see part A, a radio telescope has a larger diameter than a Newton telescope because radio telescope have shorter wavelength than visible light. That is wrong. Radio wave shorter wavelength than visible light, wrong. It should be radio wave have longer wavelength. So on that part, C, that's wrong. A, all right. Again, first part of B, a radio telescope has smaller diameter than Newton telescope, tak boleh. A radio telescope always has a bigger diameter than a Newton telescope. So the beginning part of B is already wrong. A radio telescope has a smaller diameter than Newton telescope. Wrong. It should be a radio telescope has a bigger diameter than a Newton telescope. So D is wrong lah. So leaving B as the only one correct. Right? Well, right, we come to 9:30, we can announce the result. Yeah.
Question 89 first.
Okay. So,
question 89, Dr. Chong, your question?
So now the thing is, basically there are 4 pictures here. So which of the set below are for radio telescope? You should know lah. All right. So if I know a bit, tak boleh 3 channel this. So what's 3? A solar cooker. Pemasak solar cooker. It looks like a telescope, lower parabola, but light concentrated, and you cook what? Your nasi lah, your curry lah. Okay? Your whatever lah, your hong tau sha lah. So basically, it's a solar cooker. So straight away, you know 3 is wrong. So A is correct. Radio telescope, the world's biggest single-dish fast telescope in Guizhou, in southern China. And this is our log periodic radio antenna. It's used for TV reception, but it also can be used to receive radio wave from space, radio astronomy. And this is our radio job antenna. So this is this is the radio dish antenna. This is a log periodic antenna, radio astronomy. This is a dipole antenna. So it's actually a vertical pole, but here you have 2 parallel copper wire. These are the what we call dipole antenna that will receive. For example, we have radio job project in Penang. It will receive radio transmission of the sun, radio transmission from Jupiter. So correct answer should be 1, 2, and 4. 3 cannot. Well, 3 is not a solar telescope. 3 is a what? a solar cooker. All right. So the answer should be, Lai, can you go scroll, which is the correct answer? A, B, C, D. D should be correct. 1, 2, and 4. D is the correct answer.
All
Because
right.
the other question, A and B and C got 3. Cannot be. 3 cannot be. 3 is the solar cooker.
Actually, when I first saw this question,
Yeah.
I was confused. I thought that I didn't look carefully. I realized that I thought that one is the receiver. Then I
No,
looked
look
there. I
at
said,
it.
"Hey, this is a big
It's
pot."
not 3. So you know, Lai, the radio telescope, the wire, they use a wire mesh, you know. So the wire mesh doesn't reflect light one. The Arecibo telescope, do you know that the fast telescope don't reflect much light, you know, because in between
Yeah,
the
yeah.
one got empty air, whole one got hole. So it's actually, this is a very reflective, fully coated reflective mirror. Number 3 lah, solar cooker. Okay.
Yes.
Next
So
one.
before we announce the results, we go one more question on section B. All right. So just a brief information about section B. So section B is the section we have multiple answer. So each correct answer you'll get 1 mark. But if you provide extra answer, then marks will be deducted. So this question number 91, which is the first question in section B, is actually a big trap, which trap a lot of students. All right. For question number 91, it says rainbow is a meteorological phenomena where an arc of visible light spectrum appears in the sky. So which of the following statement is true about rainbow? Now, the question number 8 says Tim could see a rainbow after the rain stopped at 1 p.m. So for rainbow, we have to first understand the physics behind rainbow. So the physics behind rainbow is actually refraction and reflection. All right, refraction and refraction. So if it is reflection, then it must always be opposite the sun. So at 1 p.m. is in the noon time, the sun is exactly above you, all right, or slightly off-centered above you. So it's still high in the sky. So if it is opposite the sun, it should be on the ground. So it is impossible for a rainbow on the ground that we see is a rainbow on the ground, right? So usually, if you realize, if you see a rainbow is early in the morning when the sun just a little while after sunrise, all right? The sunrise on the east, and then you will see the rainbow on the west, or during sunset, all right? The sun is setting in the west, and you see the rainbow on the east. All right, so A is not correct. Number B, rainbow must consist of 7 colors and only can be seen during daytime. All right. Firstly, rainbow consists of 7 colors. This is what we know, but it not necessarily must consist of 7 colors. All right. Sometimes there are people report they see rainbows, but there are only 4 color, 5 color, or 6 color, or even a monochrome rainbow. All right. So it must not consist of 7 colors, and it's not necessary that it can only be seen during daytime. All right. Even at night time. All right. If we have a full moon or almost full moon, we can see a rainbow. But of course, the rainbow will be very faint, and it might, through our naked eye, we will see as a monochrome rainbow. But if we have a camera and we have long exposure enough, okay, we can see the 7 colors of the rainbow at night. And of course, for full moon night, at night, all right, the moon is very bright, and the rainbow will appear similar to the sun, which is opposite the moon. All right. So for C, refraction and reflection of light in water droplets and ice crystal cause rainbow. The first part is correct. Refraction and reflection is correct. Water droplets is also correct. All right. The trick here is ice crystals. Ice crystal is not correct. All right. For rainbow, it only form from water droplets. For ice crystals, all right, it will form another phenomena called halo. It looks like rainbow, but it is not the rainbow. Rainbow is always opposite the sun or opposite the moon, but halo is around the sun or around the moon. That one is known as halo. So halo is caused by ice crystals, all right, not water droplets. So the only correct answer is D over here. It is rare but possible to see a rainbow on a full moon night. All right, full moon night, because the moon is very bright, so it is possible to see a rainbow. Okay, so the answer for question 91 is only D. All right, it's only D. Okay,
Like
and
your suggestion, Now maybe we can announce the result, but before that, can you please scroll to 92, 93, and to 100 to show them that some of the questions
before that, I'd like to reply a question from one of our audience. It says, back to question 89.
Yeah.
It requests to give more explanation on picture number 4.
Now, picture number 4, the moment you look at it, you will say it's nothing to do with astronomy. You look carefully, basically, the vertical pole cannot stand by itself unless there's a tying between one vertical pole to the next vertical, a kind of object. It's actually a wire, a conductive wire, a copper wire. But since there are 4 poles, that means the first 2 poles here will have one copper wire, and parallel to it another copper wire. So this is a double dipole radio antenna. So do not think that a radio telescope must be number 1, the big dish. No. Or astro dish. No. It can be number 2, which is our log periodic antenna used for your television transmission. But it can also receive, number 2 can receive radio wave. So number 4 basically is a dipole antenna. So it will receive the what you call the radio wave from outer space. But the advantage of the dipole antenna is what? Omnidirectional. The radio wave can come from any direction. The 2 copper wire hanging horizontally can absorb the radio wave, and you can, and of course, the radio wave absorbed by the copper wire will pass through a what? A pre-amplifier and amplifier. It is amplified and then detected. Whereas on the left, number 1, different. Number 1, this type of radio telescope antenna must point at the object accurately to get the signal from the object. Whereas you have for number 4, the radio wave can come from any direction. It can still detect number 4. But number 1, for example, imagine instead of the number 1 dish pointing at, let's say, but now vertically up. So you have a radio wave coming from the horizon, hitting the dish number 1. The dish number 1 cannot detect. Whereas the number 4, the 2 parallel dipole, you have radio wave coming from the horizon. It can detect. So it's omnidirectional. Whereas the number 1 and number 2 are what? Unidirectional. Come from one direction, can detect. Other direction cannot detect. All right. Whereas number 4 is omnidirectional. Omni means all direction. It can detect. So it's a 2 parallel as a double dipole antenna for radio telescope. Of course, the signal must detected on the copper wire, must be passed through an amplifier, and after amplifier will pass through an oscilloscope or the chart recorder, or even to a mini compo. So basically, number 4 is you listen to the sun. You never take a radio picture of the sun. You listen. So what is the sun's radio signal like? Shh, shh. Just hissing sound all the whole like that. And sometimes louder and a softer sound. So that's it. Okay, for number 4. Yeah.
All right. So this is, we hope Dr. Chong reply your question, Mr. Tamashi. All right. So,
Mr. Lai, can you go down? You look at 92 to 100. Show them that the question can have more than one answer. So just slowly, one by one. Don't go too fast. You're going too fast.
So before we announce the result, all right, for section B, the questions can have more than one answer. For example, from 92 up to 100, all right, 92 have 2 answers, 93 have 2 answers, 94 and 95, 96, 97 have 3 answers, 98 2 answers, 99 and 100 have 2 answers each. Okay. Before we proceed in details on the other questions, I think maybe we can announce the result first, since it is already 9:40.
So you ask Mr. Michael Teo to announce. Michael, thanks for patience for waiting. So now
we continue later. Okay. So we pass the session for result announcement first.
Okay, Michael, please put out the result.
Okay, can you hear me? Yeah.
Like how many people are following the Facebook now?
42 now.
Okay.
Okay, so can you see my screen, right?
Yes. The result, please, the result.
Okay, so ladies and gentlemen, okay, this is the moment you have been waiting for more than 1 hour. Okay, For those who have not known about this, actually this morning we have our inaugural Penang State Secondary School secondary quiz, which is conducted online. Okay, so it was held this morning between the 9 and 11 a.m. So we have more than about 156 students participate. Okay, so why I cannot see my screen?
Michael, you must mention for how many schools.
Can see my screen now. I cannot see my screen.
I cannot see your screen. Can you share?
Wait, let me check.
You must
again.
mention how many schools. You say how many teams, how many schools.
Let me share again.
Everyone is very expecting. Same screen, it's the same screen.
Yeah, no, it takes a while. Check.
It shows you are presenting to everyone.
Yeah, I'm not sure why the screen doesn't show up. Okay. What happened?
I see below there, stop sharing. Yeah, is there. Remove this poster. Behind the poster is the result. I see I'm writing behind the poster.
No, but on the Facebook cannot see. I'm not sure why.
On the Google Meet I can see.
Yeah, but wait. This is Google Meet. Let me try to share again.
Or you log out and log in again.
Still cannot.
Like, any comment? Any suggestion?
Maybe you send me and then
Okay,
I
I
share.
send to you. Okay, wait, I send to you by.
Okay, everyone, patience, sabar, akan Michael akan hantar ke Mr. Lai, and Mr. Lai will show on the screen for everyone to see on Facebook.
Downloading.
So maybe when Lai you put on the screen, let Michael explain. Okay?
Yes. 1 minute.
Sabar,
Alright.
patience.
Alright, can you all see now?
Yeah, Lai, I can see the quiz competition, but where are the result?
Wait, also wait a while, it will take as well. Okay, it's coming here. Okay, so we have.
Okay, Lai is still waiting.
Okay, so we have a total of 38 schools.
I don't see on my screen.
So we have total 38 schools and 52 teams, 156 students participating in the quiz today. Okay, so are you ready?
Yes, I think.
Okay, so we start with the third place. Okay, the winners of the third place is ASMKA Al-Masyo Lelaki. Okay, the team members are Muhammad Aiman Hakimi bin Ahmad Zamani, Adam Syami bin Sofiuddin, Jadi Faiz bin Yusuf. Okay, the total team mark is 132 over a total mark of 330. Okay, congratulations to the team of SMKA Al-Masyo Lelaki.
Tanya Aiman, Adam dan Jadi. Tanya, okay.
Alright, congratulations to SMKA Al-Masyo Lelaki. All right.
Okay, next we go to the second place. Drum roll. A little drum roll. Okay, SMK Tinggi Bukit Mertajam Team 3. Okay, the team members are Sridharan Subramaniam, Nanda Kumar, and Priyasri Kumara Arumugan. Okay, the total team mark is 138 over 330.
Yeah.
Okay, congratulations.
You must explain why each team total of 330.
Okay, so actually the quiz was answered individually. So the total, we have a total 100 question and total 110 marks, okay, per participants. So for the team competition, okay, we add up the total mark of 3 participants. So that's why we end up with a total mark of 330.
Yeah. But I mean, I add on 100 question. So section A 90 question. Each question, section A got 1 mark, 90 mark. Question section B got 10 questions, but each question section B got 2 marks. So total section A and B is 110 marks. Okay.
Okay,
Alright.
so now loud drum roll for the first place.
Congratulations to SMK Bukit Mertajam. Right.
Okay, click slowly, like. Okay, so the first place goes to Magic. SMKK Chongling Team 1. Okay, team members are Ng Kim Him, Liu Zewei, and Tan Ivan. Okay, total team mark is 158 over 330. Congratulations to Team SMJK Chongling Team 1.
So congratulations, Chongling, Kim Him, Zewei, and Ivan. Okay. Continue.
Okay, so we have a special announcement here. Okay, so initially we only planned for 3 team prizes, okay, for this competition. But after discussing with the committees, okay, we have a good news. Okay, we have add on 5 individual prize for the top 5 performers. Okay, which
Michael,
means,
wait a minute.
Yeah.
The first 3 places for the school, you must say what are the trophies you're supposed to give them.
Yeah, there will be a big trophy for the schools, and there are 3 trophies for the team members. Yeah. Okay, so now we have a surprise, a big bonus. We have a 5 individual prize for the participant with the top 5 marks, okay, in the competition. Okay, the first one goes to Tan Ivan from SMJK Chongling Team 1. Okay, his mark is 60 over 110. Congratulations.
Okay, 恭喜你, Ivan.
All right,
Okay,
congratulations,
second,
Ivan and Chongling.
Second go to Sridharan Subramaniam from SMK Tinggi Bukit Mertajam Team 3. His mark is also 60 over 110.
Sridharan, congratulations.
All right, congratulations to Sridharan.
Okay, number 3 is Muhammad Aiman Hakimi bin Ahmad Zamani from SMKA Al-Masur Lelaki. Okay, his mark is 57 over 110. Congratulations.
Aiman, Tanya, Aiman.
Congratulations, Aiman.
Okay, I know this boy.
Okay, then we go to number 4. Okay, Chua Cherry from SMJK Heng Yi Team 1. Okay, his mark is 53 over 110. Congratulations.
Right, and the last one.
And the last one is Ui Shu Hui from Penang Chinese Girls Private High School Team 1. Okay, her mark is 52 over 110. Okay, congratulations to the above 5 students with the highest mark during this competition. Okay, so congratulations again.
Michael, what's the prize for these 5 students?
We also have a trophy for each of them. Yeah, so if their team is a winning team, then they will get two trophies, one for the team, one for the individual achievement.
Okay. Michael, you must announce the certificate sigil for all the participants, you know.
That one, okay, for every participant, okay, we will prepare the participation certificate and post it to the schools. And also for the winning teams, they will also receive the sigil pencapaian, okay, as well as for the teachers for the sigil penyertaan. So all of this we will post to the schools. And as for the trophy, okay, once they are ready, okay, we will send it to the school. Okay, probably we can arrange for a photography session, okay, with the winning teams, participants, the team members, and also the teachers, okay, the principals, and everybody happy. Okay, thank you.
But one more thing is, Now, we must announce, Michael, that all the names of student teachers sent to JPN Pulau Pinang, no?
No, don't you go on. You want to add on anything? Just go on.
Oh, okay. Jadi, all the students who took part from all the teams and the name of the cikgu and the name of the school, the JPN Pulau Pinang, Jabatan Pendidikan Negeri Pulau Pinang, needs us to send it to them. So we send it to JPN Pulau Pinang. So JPN Pulau Pinang, we have a record of all the participants. JPN Pulau Pinang akan dapat maklumat semua nama pelajar, nama cikgu, nama sekolah. Okay, dalam rekod JPN Pulau Pinang. Okay.
And Michael, there are students asking whether will they get their individual scores?
Usually, I think last year we didn't provide, right?
No, we did not provide.
Yeah, usually for this competition, we don't provide individual the score, but do you think it's okay to provide? Maybe we discuss and see.
I think we discuss in the committee meeting later, or
Okay.
or my comment is if they ask personally, maybe we can provide.
Yeah.
This is, yeah.
Then maybe we'll just provide the team score or the only for the particular team to their own school instead of publicly announce it publicly.
Yeah, we will not announce publicly, but if they ask, maybe we can provide personally lah.
Yeah, sure.
Okay.
Yeah, so this is about the results announcement. Dr. Chong, any comments on the results?
So actually, before we had this session, before I start, I discussed with our Mr. Lai. So I already know that basically the background is like that. We know that since 2013, 7 years ago, we have sent teams of Malaysian Penang Secondary School students to take part in International Astronomy Olympiad, IOAA, International Olympiad Astronomy Astrophysics, IAO, International Astronomy Olympiad. So we already aware that the standard of astronomy competition international is very high. So we also expect the standard of astronomy quiz for our Malaysian schools, both primary, secondary school, should at least have some standard. So basically, we because of that kind of rationale, so I would say that I look at the general result, I would say that it's expected. Why? Because the results are not as good as many of you think. You should get an A, 100 upon 110. You look carefully, the questions are, some of them are not fully in your school syllabus. So basically, it's a very good and deep general knowledge of astronomy and space exploration, including the theory of equipment calculation. So in other words, this is like we want to prepare our students for international astronomy competition. So that is the standard we expect. So basically, I more or less expected the result that we got from today. But basically, I would say that everyone make an effort. So please work harder for the future, right? So this year under lockdown, you are not taking part in IAO. So next year, hopefully, we can take part in IOAA, International Olympiad Astronomy Astrophysics, and IAO, International Astronomy Olympiad. I've taken part in these two Olympiads before, very high standard, all right? So we are preparing our Penang students to lead Malaysia to take part in International Astronomy Olympiad, and also to lead Penang, to make Penang the state where we really have good students who knows a lot of astronomy, all right? Right, your general comment?
Yes, I make some simple comment. Firstly, a big congratulations to all the students who are doing well, all the winners, and all other students who participating. And also thank you for your support and for participating in this competition. So overall, the results is quite okay to me. But actually, I did expect slightly more. But somehow I still think did a quite good job. Okay, because the questions itself is not really very easy, and there are a lot of traps, especially the questions that I said. There are quite many traps in the question. So it's okay. Meanwhile, I think I'd like to make some comments also on the way how these questions is set. Okay. Interesting thing is a lot of questions, if you look carefully, if you read carefully, it tests on general knowledge. Okay. There are some on history, and most of it are still on general knowledge or the physics or the science behind the astronomical phenomena. So, for example, I give an example. All right, what I hope what I hope from the question I said is actually combining the history and the modern, combining arts and science. All right, and for example, many of the questions are related to our daily life. For example, question 91 about the rainbow. How this question is set is actually last week. This question was set only last week when I was having a meeting with my friends in China because I'm currently a student in China, Beihang University, and they have consecutive 4 days they see rainbows, and it's a very rare phenomena to see rainbows in Beijing. And consecutively 4 days they see rainbows. So I think this gives me some idea that rainbow is actually something interesting that we can. Why not? I just come up with a question with rainbow and put it in the quiz. And who knows, it actually traps a lot of students in these questions. So overall, my comment is I hope everyone would actually be aware of what happens around you, right? What happens around us, okay? Not only see and say wow, but also try to understand the science behind, the technology behind, right? So this is about my comment. And also, even though if this time you don't win anything, all right, I sincerely hope that you all actually learn something from this quiz, right? At least you gain something from this quiz, all right? Not only about winning, okay? The intention or the objective of reorganizing this quiz is not about, uh, let you win something or making you having some event to join to participate. But the main intention is still to hope that all our participants learn something from this session, from this quiz. All right, so this is my comment. So anything add on, Dr. Chong?
Yeah. So I just to add on to what Lai said, all right, that actually we hope to inspire our young Penang people. That astronomy is not just boring, boring, boring. It's very exciting, you know. Even now, I'm in astronomy for so many years as a hobby. I still learn new things every day, right? And then, of course, the final comment is, so this is organized by our Pertubuhan Astronomy Pulau Pinang, Astro Society of Penang. There are a lot of activity. So please be aware in the Facebook, in the news, there are a lot of activity. Follow now under RCMO lockdown. We still have a lot of online session, but and we still sometimes go to our members observatory in Bali Pulau, Cincai Observatory, Pulau Betung. And so tomorrow, as usual, every Sunday I go to the Tech Dome, Penang, Pixel Observatory, Bali Cerah Pixel, the Tech Dome Penang. So you go there, they can show you a lot of telescope. You can learn from there. So it's also a lot of things. So unfortunately for this problem, this quiz, like I discussed, Mr. Live right from the beginning, we cannot test on the use of telescope. Some of our astronomy tests, we actually want the student to come and hold the telescope and handle the telescope, testing them. But we are not able to do it here because it's online test. So later on, if we can do our future quiz, the quiz component, no more lockdown, will involve hands-on activity using your mind, your head, and also your hand. That would be nice. And that will be what? Astronomy quiz di bawah bintang under the star. We test you to point to this object, point to that object. That would be wonderful. We hope we can do that in future. All right. So thank you, everyone. All right. And
So I think, Dr. Chong, before we end the session, so I think we can continue a bit on the question discussion. If
yeah,
anyone has any questions, all right, you all can, or
uh,
which question you all prefer us to discuss, you all can type in the comment section so that we can directly go to the questions
yeah.
and discuss a bit on the questions. Because
I give a
just now,
suggestion.
just
to
now
start.
the questions, wait, Dr. Chong, wait.
Yeah.
Because just now the questions that we discussed is the questions that based on your performance. That means those questions that more students make mistake in. But now is the opportunity for you all to select the questions for us to discuss. All right. So you can just simply type in the numbers in the comment section, and we'll go to that questions for further discussion. All right. Dr. Chong, anything?
So my suggestion is before they come up, put in the Facebook, the comment, the question. Why not you start the ball rolling is question all in section B. You discuss 91. You go to others because
All right, then
harder question.
we continue with question 92 first before we wait for questions. All right.
Yes.
So let me share screen. All right. Now, question 92, hopefully you all see. Okay, we proceed with question 92. Question 92 talk about slash and burn. All right. We are living in Malaysia, and I believe every year, especially last year, slash and burn affects a lot of us. All right, because it's a practice in many agricultural countries, which is after they harvest the crops and then they after they harvest the crop and then they will burn. Okay, they will burn the leftovers. So it's commonly practiced in Sumatra. So when every time when they harvest, after harvesting, then they will have this slash and burn. So what happens after slash and burn is we were seriously affected by haze. All right. Of course, some students are happy with the haze because if the haze is too heavy, then the schools will lock down. So this is something that affects us every year. So not only affects our daily life, but it also affects astronomers, affects uh, the astronomy, the interest in astronomy. All right. So the question says, after a week of API above 300, it finally slightly decreases. All right. So Peter decides to have a simple stargazing session at his balcony. Okay, what is or are his expected observation? So under his condition, what are we expect to see? So for bright stars or for moon, we can actually still see the stars. We can see the moon, right? But the stars or the moon or the other objects in the sky will appear dimmer, of course, all right, and also more reddish because of the dust particles in the air. It actually absorbs some of the blue wavelength, so it appears more reddish, all right. So if it is a hazy day, you look at the moon, okay, the moon will be more orange or slightly reddish, right? This is because of there are more dust particles in the air, in the atmosphere. So actually from observing the sun, right, you can actually make a simple evaluation on the air quality. If the air quality is good, then you see the moon is more yellowish, more bright. But if it is more reddish, that means the air quality is uh, not that good. All right. So actually, we can use astronomical knowledge, okay, in evaluating our daily life quality, like our air quality. Right. For question 93, is about the PP chain, is the nuclear fusion in the sun. Just now we actually did discuss about the nuclear fusion in the sun, but somehow that one is the general one. Okay. This is the detailed one. All right. On the PP chain, which is the very first reaction that happens in the sun. All right. It's basically fusing hydrogen. All right. Fusing of two hydrogen atom or two protons into a hydrogen 2 atom, or we call it a deuterium. It's a hydrogen isotopes and form a positron. Positron is a positive electron and also a neutrino. Okay, and then we have the hydrogen 2 fused with another proton or fused with hydrogen 1. All right, and then it will form a hydrogen 3, a helium 3, sorry. Okay, it's a helium isotope, right? Helium isotope with gamma ray. These are the two main one, the two correct one, which is the two very basic reaction, all right, happening in the sun and most of the stars, all right, which fuse hydrogen into helium and heavier element. So question 94 is talking about terrestrial planets. Terrestrial planets are the planets, or we call the inner planets of the solar system. Basically consists of Mercury, Venus, Earth, and Mars. All right. So we are solid rocky planets. All right. And the question says, which of the following descriptions of interior of terrestrial planets is or are false? All right. So the false one, the not correct one, is all terrestrial planets have a solid core with iron as the main element. Iron is the main element for core of terrestrial planets. This is correct, but solid core is not correct. All right, because Mercury, Venus, and Earth we have solid core, but for Mars, all right, scientist studies or research shows that it have a molten core. That means it's not a solid. Okay, it's a slightly liquid state. Okay, so it's a liquid core. And Earth is the largest terrestrial planet and does have a largest iron core. This is not correct. For Earth is the largest terrestrial planet, is true, but the largest iron core does not belongs to Earth. It belongs to Venus. All right, Venus have the largest iron core. And also, question 95 is about amateur telescope making. Amateur telescope making is actually a very fun project, interesting project, which means you make your own telescope at home. All right, make your own telescope. So making our own telescope, all right, we not just only do the telescope blindly, all right, we have to make sure that the performance of the telescope. So after you do the question say after completing parabolizing the primary mirror of the telescope, what tests should this Daniel do to confirm the primary mirror is well parabolized? So there are two main tests you can do, which is focal test and Ronchi test. All right. Curvature test, there's no such thing in optics. All right. And for Slerian test is actually aerospace or aeronautical test to observe the change in density of fluid flow. So Slerian test is commonly used, all right, to observe shock wave. So this is not a test to make sure that the primary mirror is well parabolized, but focal test and the Ronchi test is the one. So next 96, Vogt-Russell theorem. So Vogt-Russell theorem is a theorem to determine the structure and evolution of stars. Determine the structure and evolution of stars. So basically, this equation, it uses two main parameters, which is the mass and composition of the stars. All right. So you can look more on this Vogt-Russell theorem. And number 97, all right. Number 97 is early Big Bang, temperature extremely high, particles can be created out of radiation field. So following statements about creation of matter is true. So basically all is true except B, which is for negatively charged electron form, it should be a positively charged electron was formed, okay, at the same time. All right, not a positively charged neutrino was formed at the same time. And for question 98, is about these barriers in flight history. Now, the three main problems in the early days we face in flying is the sound barrier, the thermal barrier, and the blackout zone. Sound barrier, we have solved it, all right? That means we use an afterburner in the jet engine. So we have a turbofan engine, which can accelerate and break through the sound barrier to travel faster than speed of sound. But thermal barrier and the blackout zone is still the main problem that we face. All right, thermal barrier happens especially when hypersonic flow, especially spacecraft re-entry. All right, spacecraft re-entry. In this case, the temperature is so high, all right, which will cause deformation on the structure. So that's why thermal barrier is currently still a hot topic in research, and also communication blackout zone. That means during re-entry, because of the heating, okay, there's a layer of plasma which isolates the spacecraft from signals. So when re-entry, especially for human mission, we experience a blackout zone. That means loss of communication for about a few minutes to a few 10 minutes, around 10 minutes. So within these 10 minutes, it actually depends on fate, whether you survive or if nothing happens within these 10 minutes, you are lucky enough, you will land safely. But if something not good happen, then it depends whether you survive or does not survive. And this is the high risk period during this blackout zone. Of course, the other two is a big problem, but it's not the barrier of flying. All right. Icing of spacecraft or aircraft is a main issue also. But then to avoid formation of ice on spacecraft or aircraft, this one is still is also a hot topic in research, but there are many precaution steps, many ways, all right, for many precautions or many measurements can be done to avoid icing or to solve icing issue. While congested space debris are orbiting around Earth, this is what happens in recent years, because after the missions end, we don't have a effective way to bring all these so-called end of mission satellite back to Earth, right? We can only slowly wait in the orbits and return to the Earth when they re-entry and burns out in the atmosphere. So the space debris issue is still a big issue, but then it's not actually a barrier to us, because this is created by human beings, but not naturally exist, such as the thermal barrier and the blackout zone. So I used to say that if you want to be the richest man in the world, you can come up with solution to clean the space debris around the Earth, then you can earn a lot of money from that. All right. And we go to the last two questions in ISS, talking about the solar radiation. This question is about astrobiology. So overall, we have for most of the crew in ISS, their missions, currently the longest time for their mission is 6 months. One of the reason is the mission lasts for 6 months is because to reduce the time they are exposed to the solar radiation. All right. So one of the method is to reduce the overall mission duration of the crew members in ISS, and also use hydrogen-rich materials such as polyethylene shielding materials. All right. This is the precaution steps applied in ISS. Meanwhile, for B, consuming vitamin A, C, and D supplement to prevent radiation damage. Actually, for vitamin D, okay, they did take vitamin D. Vitamin A and C, I'm not sure, but then it shows that they actually did take vitamin D supplement, because in the ISS, it's a fully isolated environment. So they actually the astronaut is lacking of vitamin D, which is from exposing to the sun. Right? On Earth, okay, daytime when we go out, we experience the sun, or we enjoy the sun, or even in those country with winters or fall season, during summertime they like to go for sunbathing. So this is a way that we obtain vitamin D. But somehow astronauts in the ISS, they actually do not have it's not healthy, or it's not good to direct expose to the sunlight, because on Earth, when we expose to the sunlight, we have the atmosphere which filter away all the harmful gamma rays, all the harmful substance, all the harmful rays from the sun. So in ISS, it's outside the atmosphere, so they are not the solar emission, okay, is the solar radiation is outside. It does not pass through the atmosphere, so that's why they are not encouraged or not allowed to directly expose to the solar radiation in space. All right, and using thick cement is not a precaution method by ISS, because thick cement is very heavy, so it's not practical to have that. And the last question, okay, we have also two answers. All right, it's about the EHT, which is capturing the image of black hole. So there are involved 8 telescopes in this EHT, but the largest telescope refers to the FAST telescope, which is in question 89, the first picture. All right, that one is the largest telescope we have, which is 500-meter aperture. All right, that one is not part of EHT. And the northernmost radio telescope is the ICAS, located in the North Pole. That one is also not part of EHT. That one is for aurora hunting, is to study aurora. So that telescope is not part of EHT. Whereas the most expensive ground-based telescope in operation refers to the Atacama, the ALMA telescope, okay, in Atacama Desert. So basically, C and D is the same, located in the driest place on Earth. The driest place on Earth is the Atacama Desert in Chile. So these two, okay, is the same telescope, referring to the same telescope, which is placed in Chile and is part of this Event Horizon telescope. Right. So this is about section B, the answers for section B. So I don't see anyone posting any questions. So any comment, Dr. Chong?
My comment is, if I'm a student, with the performance I get, imagine I'm one student, in a sense, I realize what so much thing involved in astronomy one, theory, and then calculation, and then space mission, and then all kinds of things involved, properties of material. So it's not as simple as you think. It covers a lot. So basically, if you really can do well in this quiz, you have a good grounding, at least a general knowledge of astronomy. So I hope that the performance of the student, whatever the result they get, like what Mr. Lai said, is not that important. The importance is whatever performance they get will spur them for greater efforts in the future. 更加油啊! More to work more for the future, not only for the first three school, the first three and the first 5 top performers, every one of you, all right? Because what astronomy is what? Physics, mathematics, chemistry, exoplanet now discovered, life in biology. So basically, astronomy is the only subject we know that covers physics, mathematics, biology, chemistry, and in fact, astronomy, you will look at the culture of ancient people to modern people. Astronomy covers actually all knowledge of human behavior. All human activity is some other related to astronomy, including ancient history, not so ancient history, and modern history. Astronomy related. All right? Okay. That's what I want to say.
Yeah, just a comment from one of our audience just now. He said he actually see a lot of historical questions, but actually, if you look carefully into the questions, the questions that really test on history is not much. All right, it's quite little, but it tests a lot on the scientific background, but with scientific knowledge. But then we actually did give a lot of historical background. The reason we provide historical background is to show that all what we have today doesn't only occurs now. All right, it actually happens long time ago. All right, so this is why we give some historical background, and also we give some you might find some questions are quite long. So this is why we have so many of the questions, in fact, the front part is telling you about the story. It's about storytelling. So this is actually how you would like to just a simple information is so that you actually know what is happening and also what is the science behind. All right, so this is
My general comment is
Yeah.
that maybe I may be wrong, but maybe the person who asked the questions like that, they think that the question in the quiz should be similar to the question in the school. But the school syllabus is actually very narrow. So what we want to expose the student in this quiz competition is astronomy is more than what you learn in the school. It's actually very wide. So we try to cover here and there as many topics as possible so that you have a good exposure to every part of astronomy. So it's not astronomy taught in the school, not the question, it's the astronomy that is part of astronomy. The question that if you can understand general part of astronomy in every aspect, this is what we expect you to know. All right, not what you expect the teacher in teaching astronomy in your school to give you the question.
Yeah, true. Just for everyone's information, our question actually covers from the basic introduction of astronomy, and then covers slightly bigger up to the solar system, and then the deep sky object, and we even have practical part. All right, we discuss about telescope, discuss about observation, and then we have cosmology, we have astrophysics, we have astrobiology and space exploration, and even a little bit of radio telescope. So this is what we cover for the quiz this year.
And also, I like the two questions is the two Malaysian astronomers, Dr. Noor Hafizah from UIAM and Dr. Kevin Kueh, who is now working in Taiwan, Malaysian astronomers, who have made big discoveries in astronomy with their team. We are very proud of them. So we hope that in future we can set more questions of famous discovery in astronomy made by Malaysian astronomers. Yes.
Yeah, so that's it from me. Anything else from Dr. Chong and Michael?
Yeah, that's already for me good enough. All right. So I think live we need to have a good rest.
Yes.
Question not easy.
Kill a lot of brain cells.
Not easy, not easy. So actually, Michael, I made a general comment earlier that the result they got is more or less what I expected lah. Because we know the background of the student in Penang and Malaysia, so we want to uplift the standard of astronomy in Penang school to a higher level. We want to bring it up to a higher level. Okay, so it goes on like that, and we send more Malaysian Penang students for IAO, IOAA. Then the standard of astronomy in the school will be uplifted tremendously.
Yeah,
Thanks
so
to-
hopefully next year the students will perform better because this year they know our standard, so next year they can do better.
Yes.
Hopefully they feel encouraged and rather than got scared away.
Yeah, hopefully they are not been discouraged through this, and hopefully we can see them in 2022 where the next round of astronomy Penang state level astronomy quiz for secondary schools will be held in 2 years time, which is 2022.
Yeah.
Next year we'll have for primary schools.
Yeah. We hope Lai will be always with us. Dime also everyone. So by the way, Lai and Michael, after we log off from Facebook, I want to discuss with you a bit on this Google Meet. You log
Okay.
off from
Yes.
Facebook, I don't have a short discussion with you. Okay,
Yes, I think we end the session now.
Okay, so everyone, thank you for joining us tonight.
Thank you.
Okay, so we are going to end our session
Okay.
tonight. So good night, everyone. Thank you.
Okay,
See you again
congratulations
next month.
everyone.
Yeah. So Ken, we are out of the loop already. Only 3 of us. So basically, again, I repeat, the performance is more or less what I expected. Good, the question is good. And the other one is, you can do this. I challenge that we can send our question to the university student in USM, in UKM, in UC, maybe in NUS. See whether how many can answer correctly. Not easy, no, not easy. Very good test, right? And by the way, our first team, Ng Kim Hin, is actually the Chongling Club president, the new club president. I know him well.
Wow.
And Ziwei also, Liu Ziwei, I think he's one of the committee members. I know him well. The third student, Ivan, also well. So Kim Him and Ziwei, I know them well. So I'm not surprised because they must have worked very hard on it. And you know what? They're only Form 3, you know.
Form 3, surprisingly, yeah.
All the boys are Form 3. So
I
good,
thought Form 4.
I was Form 5 only. So good material for IAO, IOAA. Good material.
Yes.
Yeah.
Okay, so I think we end here. Yeah.
Okay, we end here. Thanks a
Okay,
lot, Michael.
thank you, everyone.
but-
Okay, good
I
night.
did a follow-up.
One more comment is, Dr. Chong, you said we should share the answers, right?
Yeah. I
that-
think, to be fair,
Yes, we should share, but I personally disagree we share on Facebook. We
Maybe
share,
privately. Yeah, maybe privately. Yeah.
okay.
we should share on our website. I think we should share on the website, but not I don't really agree to share on our Facebook because I have lack of confidence of the Facebook security.
Yeah. Okay, Ken. The problem is, if you share even privately, you send the PDF file to one student in, let's say, in Amaso or Lucky, they're going to spread out and put on their website. That's the problem. That's the problem.
But never mind, I think we'll discuss it later.
Discuss later.
Yeah.
Thanks, Michael, for a long
Okay,
day.
sure. Okay,
Thanks,
sure. Bye.
Live, and of course, Dime also behind. Thank you,
Yeah.
everyone.
First time our watch more than 40.
Yeah. You know, Live, remember in our ASP community online meeting some months ago, we discussed that we want to do this year's secondary school quiz. I said, very difficult. No, I just only about 6 weeks. I thought where it can come, and finally we made it live. We made it. We
All right,
made it.
okay. Okay.
Not easy, no.
Yeah. So we continue later also.
Okay, lah. Thank
Okay,
you.
good night, everyone.
Good night, Chin Chong. Okay, live. Good night.
Bye.
Okay.